grade 12s. If you are reaching this point of rules of differentiation, then it most probably means you've started with calculus and you've done a few derivatives using the first principles, or finding derivatives using the first principles. And you've noticed that finding the derivative using these first principles can actually become a bit tedious and a bit long. Okay, and very um, uneasy to work with in some cases. Now, luckily for you, there are a few rules of differentiation that we will be able to use to actually find the first derivatives very easy. Now, these rules of differentiation in grade 12, especially normal or pure mathematics, is a little bit limited to what all the other or all the possible rules, but we focus on a few. First rule when it comes to rules of differentiation is that if I tell you that your function f of x equals to a times x to the power of n, and you want to find the derivative, then all you do to find the derivative is you take this exponent, you multiply it with the coefficient in front of the a. So in other words, you're going to say a times n. You're going to keep the x, and what you're going to do is you're going to subtract 1 from this exponent. Now, if you've done a few first principle calculations, you've probably also noticed this pattern that you essentially take the exponent, multiply it with the coefficient, and subtract 1, and that then also gives you your derivative. Now, another rule that we have essentially that is if you have a function or some type of equation or expression that is given to you by a few terms, where you have one term, add another term. Let's not make that g, let's make that a h, plus another term, for instance. Then a very easy way to find the derivative of this function or this expression or equation is to take the derivative of each term on its own. So meaning if you want to find the derivative of f of x, you're going to take the derivative of the first term, add it to the derivative of the second term, and then add it to the derivative of the third term, and so it continues. Now there's a similar rule for subtraction as well. So if you have f of x which consists of a few different terms, so one term minus another term minus another one, then essentially when you want to find its derivative, you're just going to take the derivative of g of x, subtract it from the derivative of h of, or subtract the derivative of h of x, subtract the derivative of z of x, or the different terms. And all of these derivatives you can actually find using this very first rule of differentiation, where you take the grade or the exponent multiplied with the coefficient, subtract 1. Now something that's very important to note is that the derivative, or if you have a function or some expression that is a constant, okay, k is a constant in this case, then the derivative of a constant will always just be 0. And using these rules, we can then actually find the derivative of a few expressions and functions and so on very easily without needing to go to the back to the first principles and using those long tedious methods. Now, a few things before I actually want to get to the rules of differentiation is some of the different notations you'll see. And all of these notations actually mean the same thing. I can ask you to find the derivative of f of x. That means I give you f of x and you need to find the derivative. That means the exact same thing that if I tell you y is equal to some expression, then I can use, or I can ask you to find dy dx. That means you need to find the derivative of y in terms of x. And also something that you'll see that, let's say you have an expression, so a to the, or ax to the power of n plus ax to the power of whatever, and it continues. Then if I want to find the derivative, I'll simply just say d dx or dx, and then in brackets, I'll write down the expression. Now, all of these things are different ways of me asking you for the derivative. So if you see this f prime of x or f apostrophe x, that means I'm looking for the derivative. If you see dy dx, you know that I'm looking for the derivative, or I'm talking about the derivative. Or if you see brackets with a dx outside, you know that you're asking for the derivative in terms of x. And when I say in terms of x, that basically just means you use your x to find the derivative. Everything else you use as a constant. Now let's do a few examples. Now we're going to start off very simple, and I'm going to ask you to find the derivative of of f of x equals to 3x squared. Now this is going to be a relatively simple and straightforward one. There's nothing weird to it here. So simply when I want to find the derivative, and you don't need to write this step, but I'm going to include it here just for illustrative purposes. You are going to take this coefficient, you're going to multiply it with the exponent, then you're going to take your x with the exponent and you're going to subtract 1, which is going to give you 6x to the power of 1, which is just 6x. Now, you could have immediately just said 2 times 3 gives me 6, subtract 1, and that gives me the x to the power of 1. So you don't need to show this step. But while you still get used to it, you can use it just to keep reminding yourself that you're taking the exponent, multiplying it with the coefficient, and subtracting 1. Now, I would suggest that as we go on, before you actually just listen to me and watch me do it, pause the video and try a few of these examples on your own. So another example then is finding the derivative of f of x being equal to negative 2x squared plus 3x minus 2. So now I want you to find the derivative of this f of x. Now again, there's nothing too weird in regards to this, except that we, instead of having one term now, we have three. But that is not a crisis for us, because we know that to find this derivative, we are just going to find the derivative of each term on their own. So you're going to go to this first term, you're going to take 2 times the negative 2. So I'm just going to include that step one more time here. That 2 multiplies with a negative 2, so you go there. You have your x to the power of 2. Now you have to subtract the 1. You do the same with the 3x. That's going to be 3. The exponent there was 1, so it becomes 3 times 1. X to the power of 1 minus 1. And we know that the derivative of a constant is just 0. We simplify this. This gives us minus 4x to the power of 1, which is just x. And over here we'll have 3x to the power of 0, but x to the power of 0 is just essentially 1. So that just means we have 3 left. Now again, the only reason I'm showing these two steps was just to remind you that we're taking the exponent, multiplying it with a coefficient, and subtracting 1. So again, these are not necessary to show. But as you get used to it, you'll start kind of just forgetting about them and just applying the rules of differentiation. So that was a few easy questions. Now, when we get to our next examples, something like f of x being equal to x squared over 3 plus 2 over x to the power of 3. You'll notice now that we have fractions. And something that before you try to ever finding the derivative here is make sure your variables, or in this case your x, is in the numerator. Now, the only reason I give this suggestion is because to find the derivatives of fractions, especially when x is in the denominator or your unknown is in the denominator, you are going to require more rules. And that just ends up making it more things for you to remember, and it makes it more complex. So all you are going to do is to avoid those extra rules, we are just going to take these x's and move them to the top of the x fractions using the exponential law that says if you have something, or if you want to move the position of a value in a fraction, you just need to change the sign of the exponent. So x to the power of negative n is the same as 1 over x to the power of n. And in this example, that means this first term does not bother us. And then from there, we move this x to the power of 3 up. So it becomes 2 times x to the power of negative 3. And again, the only reason we're doing this is to avoid extra rules, um, and just to focus on those three according to the caps. Now from there, all of our x's are in the numerators, and now we can find the derivative. So we're going to take this 2 multiplied with the coefficient in front of the x, so it becomes 2x. We subtract the 1 from the exponent, so it's just 2x over 3. For this one, we are going to say minus 3 times 2. It's going to give me minus 6 x to the power of negative 3 minus 1. So we're going to have negative 3 minus 1, which is just the same as minus 6x to the power of negative 4. Now, normally we would like positive exponents, so you can rewrite this using this same exponential law as 2x over 3 minus 6 over x to the power of 4. But nowadays we aren't too um, strict on ensure or having the exponents positive for these types of questions. Okay. Another example here that we can do is y equals to Another example we can do is y equals to 2 to the power of, or 2 times x to the power of 2 plus 3x minus 5 over x squared. And again, in this case, since we have fractions and we have x in the denominator, it is a good idea to rewrite this so that this x in the denominator there comes to the numerator. Now, something we can do is we can essentially break this fraction back up into the 3 separate fractions that formed it. And then we can simplify, so this just becomes 2 plus 3 over x minus 5 over x to the power of 2. And then we go back to the previous example where we get all of the x's in the numerator. So this is the same as 2 plus 3x to the power of negative 1 minus 5x to the power of negative 2. We apply our rules of differentiation. So I'm finding dy dx now. Note that when the moment I start finding the derivative, I no longer say y equals 2, but I'm saying the derivative is equal to the derivative of a constant, that's 0. It's going to be the derivative of the next term is going to be minus 1 times 3. That gives me minus 3 x to the power of negative 1 minus 1. That gives me negative 2. Then a negative 2 times the negative 5. That gives me positive 10 x to the power of negative 3 minus 1. That gives negative 2 minus 1 gives me negative 3. So this derivative is negative 3x minus x to the power of minus 2 plus 10 to the power of x minus 3. If you really want to, you can rewrite this exponents to be positive. So it's minus 3 over x to the power of 2 plus 10 over x to the power of 3. Now I want us to do 2 more quick examples, and these examples as follows. it is, I'm asking you to find the derivative. Let me use the notations rather. I'm asking for dy dx if y equals to pi squared x plus pi cubed minus the square root of 5. Now, at first glance, this looks interesting, but remember, everything without an x is typically now just considered a constant. So if I take a look at this first term, what is the exponent of the x? The exponent of the x is a 1. So that means I'm just going to say 1 times pi squared, which is just going to still give me pi squared. And this is going to become x to the power of 0. Plus, this pi to the power of 3 does not have any x, meaning it's a constant. So that means your value or the derivative would just be 0. The same thing applies for the square root. It does not have any x's, so it's considered a constant. So it's just going to be minus 0. So the derivative in this case would then just be the pi squared. One last example then is that find dy dx, or the derivative of y, or find the derivative if y equals to x cubed minus 5 over x squared plus 2 over 3 square root x to the power of 3. And now we have a square root here, but we'll sort that out. Now, first things first, we want to get all of our x's to the numerator, so it becomes x to the power of 3 minus 5x to the power of negative 2 plus, and over here I am going to take this root and I'm going to use the exponential law that says that if you have a certain root, you can rewrite it as an exponent by taking the power of the root and dividing the exponent on the inside. So in this case, it would be m divided by n. And in this example, it would be x to the power of 3 over 2. So in my next step then, can just bring that x to the numerator as well. So it becomes 2x to the power of 3 over 2 over 3. And now you find the derivative. So I write dy dx because I'm finding the derivative. The derivative of x cubed is just 3x squared. The derivative of minus 5x to the power of negative 2 is going to give me positive 10 x to the power of negative 3. And then lastly, we're going to say 3 over 2 times the 2 over 3. So it's 2 times 3 over 2 over 3, and this is going to become x to the power of 3 over 2 minus 1, which is just going to give me a half. We simplify this, and it's 3x to the power of 2 plus 10x to the power of negative 3, and then these 2's cancel, this 3's cancel, and you're just left with plus x to the power of a half. And that, in a nutshell, is all of the different possibilities we can ask you regarding differentiation on a grade 12 mathematics level.